Today's podcast, we are going to cover about energy systems to intelligence, and it naturally flows from electrons to data to decision making till the decarbonized future. We have a very prolific guest with us by the name of Karthikeyan Doraiswamy. And let me start with this very generic question. Where a person from 1996 were to appear in 2026, what would you tell him or her how the world has changed and how it is working now?
First of all, great meeting you and looking forward to a good discussion now. And while answering to your question, we had almost a generation shift there, and we are now roughly looking at about a complete behavioral and it's a complete behavioral and cognitive shift that that the human has undergone with the change in the or with the advancement or adaptation of the technology. So that's a phenomenal shift is what I should say, and which has kind of really looked at rewiring the entire system, connecting with what they were capable of earlier and what has now been shifted to use more offloading, for example offloading the memory of a person, basically to remember something, a capacity to remember and use that for a day-to-day life. For example, starting olden days, I still remember my parents and even myself, I was able to remember the telephone numbers, but that's not the case today. Nobody really bothers to do that.
You don't have to.
You don't have to, because it's just, that's a very basic thing, but I'm really taking forward even the more important things, probably if could come from the human brain and put it for utilization at that instance when it's required. We have shifted from there completely. We have shifted from there, and we kind of have completely gone into a stage where we offload it completely to more of a digital gadgets. And when I say
because
offload,
if you take 1995, that particular person who has come here to this era wouldn't even know what a digital gadget is. Or
true, absolutely.
It
was not even foresighted that there could be some handheld device which would be capable of doing everything a computer can do to that extent, or even more advanced today, if so as to say. So today, the computing has come more at an edge level. Like you can do anything and everything at your palm. So that's the shift that I can clearly see.
That's the vision
the kids today carry, and what we back those days. But I'm very one thing that I would love to say is we had been fortunate to see this development and the revolutionary changes that has happened. Not just in a normal, in a social ground, but even on an industrial side where we worked. My career basically started with I should say Industrial 3.0 is where I really got into businesses and started working.
Can I ask what's Industry 3.0?
So Industry 3.0 basically looks at it's a preliminary stage of adopting to automation. It's basically a framework which was all defined. Everything used to be in papers. All processes used to be in papers. So you have to follow the processes in paper, have it move to the next stage in the workflow. So that's the case, which was basically a good foundation set for the next level of development, which is Industry 4.0, where everything started with automation. 3.0 had MRP and MRP2, which is like, the manufacturing resource planning at multiple level. It got some development in that as well. And then computer age came, where computers started adapting to all these things. And the shift happened, that entire thing shifted to ERP. And now we are moving everything from SaaS-based and ERP to AI applications. So that's where the entire industry today works on. So there's been a phenomenal shift that has happened, and adaptation to this by human brain, by the new generation, it's pretty fast, and they are able to cope up with that. And one, obviously, for the reason that throughout this journey, the capacity of human brain to, kind of, well, I use a word called rewiring. So basically, it could reconnect with the new neural forms of what exactly could be the easiest way to adopt things, or more productive way. I would not call it easiest way, productive way to switch to the next one. And certain things which need not be remembered, we kind of outsource it to the devices outside,
Yeah.
and retrieve it from device, apply it, and be productive. So that's a whole shift that I could see between what we had those days and what we are here today.
I think you have shifted even 5 or 10 years more ahead. I think in the span of 2036.
Absolutely, absolutely.
Yeah, because that's a good segue, because even though that person comes here, that same person would apply the things that he was part of, like say 10 years before 1995, which is 1985 or something. But even back then, like I remember vaguely Steve Jobs saying all the things that we would be having at this particular era back then, because all the things that we have now has been developed and was being developed actively back then in 1950s and 1960s.
That's true.
We were severely limited by resources, and as well as like computing and all the things. And once we started pioneering into those things at like middle of 2010s and 2013s with the growth of GPUs, we started exploring into these era where we can accelerate all the things that were on paper into like large scale. And now start of 2020s, we have ChatGPT at all our palms, and that's been like a pen to paper thing from 1950s. So
True.
yeah.
True. Absolutely. I totally agree. There is, see, on the other side, if you see, the adaptation has had no limits. Basically, anything to adapt. The limits, we were with a kind of a conservative approach back then, about 3-4 decades back when we were kids. But when I say limits, it's more of a the capacity constraints that a family could have of bidding for a device. Today, all that has been made easy with different financial assistance that's coming in, and anybody who is new into the job market or new into getting on starting with his career is still being in a position to afford something, where the banking system is such a way that there are certain financial aid that's being given on, quickly adapting to the technology and embracing it, and to look at much forward way of moving forward and getting more benefits out of what could not be achievable if you don't really adapt to those technologies.
Yep.
You'll be left behind.
Yeah, true. So all the things that we were talking about, do you think that this has started to be like a new operating system for our entire civilization? Because we have been operating it in different levels.
This is a new platform that we are sitting on.
Yeah.
And this platform has certain prerequisites to adopt, and certain things that is outdated would not fit into this platform straight away.
Yeah.
So everything, you have to upgrade yourself. You have to be latest with your skill set. If you're really looking at somebody to go into entering and beginning your career, you begin your career during your high school and at that stage, because today there are kids who even come up with a startup idea at the grade 11 and 12.
Yeah.
So
True.
how does that all happen?
Yeah.
It's all the
Where does it start?
facilitation and the environment that's around, which facilitates the entire thing. When I say it's environment, it's the infrastructure that's being made available, and how this infrastructure is being made available to you, right?
Yeah.
And what way a country's government is incentivizing this, basically, to let more and more of innovations to start. So that, luckily, I should say, in India, we have been really fortunate to get that kind of groundwork that's been set up, so that the kids or any researchers or anybody who is into an innovation mode or innovative ideas, who come up with the startup ideas, have a good facility or a ground here to get started.
Yeah. Lots of incubation
lots
centers,
of
lots of
incubation
investors.
centers. Simply take this example of the computing need today with the AI requirement.
Yeah.
It's all about connectivity.
Yeah.
The moment you have connectivity or connections made, it calls for data.
Yeah.
The moment there is a connection, you have data accumulations there. Why do we accumulate this data? To do some processing and get some additional work done out of it, or get more insights to operate something what we had been operating earlier on an automated way. We are making it more autonomous.
Yeah.
Right? So there is a volume of data that gets increased, and going forward, there's going to be huge and unimaginable. So when that's going to be the case, how do we operate this data? India, at least in the recent few days, we had been really looking at the computing needs, basically to kind of any kind of AI deployment would definitely need a lot of computing power.
Yeah.
Right. So that computing power, even be it for testing, be it for anything to experiment, any innovations, researchers, all this needs that access. So we had been fortunate to see all these accesses have been made in a centralized way, where GPUs can be hired, a space in GPU can be hired, and anybody can plug and play and get started.
Yeah.
There's so much of infrastructure that has been put forward for us, and there is about 10 million people, new, also including the old timers, are all being trained in AI.
Yeah.
So that kind of facilitation has happened in our country, fortunately. So that's all going to really accelerate this journey and lead us in a faster pace to cope up with the world. And where we stand in terms of capability towards AI deliverables, as well as more of data center setups, which is again required for the AI to operate. So that's where we stand today.
Yeah, I think diving deeper with what you were saying, like infrastructure is key, and even for infrastructure, energy is even more predominant. So with touching with all the experiences that you have, we know that electrification by itself means like moving power, but when you add a layer of AI, sensors, intelligence to it, electricity suddenly starts thinking, like per se. How do you think that paves way for scaling AI?
See, when you say AI, it's we could simply see that the AI, the basic thing, it's been layered at 5. There is a 5 layering of any AI system to be taken, right? So the first layer sits on the application, and the last layer being the energy. So in between, you have data, you have the models, and the most important thing, the chip and the infrastructure. So energy is something that starts. It's no more a different thing. It's part of this infrastructure for setup. So if you call for a data center, you need huge amount of energy. You need any displays that you're seeing which is running around, and any kind of can even take a new screen and certain things that's being running. It's all huge data that's flowing from different and getting streamed there. A lot of power is required. Any computation requires a lot of power. So energy is kind of a backbone to the entire new revolutionary I may call it as a advancement in the technology. So that's one thing that all the countries are now really running behind, and because we had a good lead on development of technology, but I think the entire world has lagged behind in catching up with the energy needs to go along with it. So that's one area we are all catching up, different forms.
Because we need to meet the environmental aspects of it as well.
Absolutely. So when it comes to Industry 4.0, the next stage is the 5.0 is, or what we are calling the fifth generation of industry. So that definitely calls sustainability as one practice to go along with it. As a matter of fact, 4.0 had laid the foundation for it already. So now when you wanted to bring this energy being made available to a particular data center or to a particular computing area, you have a traditional fossil fuel based energy sources,
Yeah.
right? So that's not sufficient going forward. If you're really looking at what exactly, not exactly, I would not call an exact number here, but there is an estimation that going forward with the volume of new technologies that's going to come in and the data computing need and the power requirement towards that is almost 3 times of the available nuclear power across the world. I would say around the world.
Yeah.
Right? So the existing is one of third is what we have now. So this is only the nuclear power, which is like a highly potent energy, and you have a huge volume to be produced there.
Yeah.
Now we are sitting on solar, we are sitting on windmill, which are all renewable energy, which again gets into the grid and forms a smarter consumption pattern. Looking at utilization of a proper AI tools, softwares around that, data management, running it through the right, the ecosystem of data warehousing, whatever is that's necessary.
And the models that run on the
Obviously,
infrastructure,
all this becomes part of
as
it.
you said, like the 5 pillars becomes like a holistic system.
Right. So that's something to cope up with this. The one thing is all direction of energy production has to happen, which could be from renewable sources, which could be from the coal based one, fossil fuel based one, cannot stop. It has to go on. Right. So additionally, there is also talks of nuclear coming back with SMRs that's going to come in. So SMRs are basically small modular reactors. So that kind of works on a kind of a fusion based method, technique rather than the conventional fission based one. So here the basically it's helium and hydrogen isotopes that's being kind of fused to produce energy. And this comes in a modular size. So something starting in the range of 25 megawatt, 30 megawatt, that size, or even 300 megawatt capacity.
Just to scale, what can that power at that scale?
That can power, for example, a 30 megawatt of a SMR can power a data center.
Okay.
A medium-sized data center, it can power. So you kind of do away with the transmission losses, the cost of transmission of this power, and especially when it is a gigawatt of power that's getting generated somewhere and has to be transmitted a long way to bring it to the consumption side, which typically the huge volumes are going to be consumed from data centers and other similar applications around the world, not leaving the quantum computing, which is getting picked up for some time, right? So these are all huge energy guzzlers. So to feed all these things, definitely different form of energy or different sources of energy have to be explored, again staying in a sustainable mode and not still being part of meeting the sustainable goals while we develop this on the parallel side.
I think let's take a route to understanding if when machines started seeing things with the advent of like high-end cameras and vision models that are being applied, there is this different trajectory that each and every company started taking. What does it actually mean for like systems to start visualizing things?
So we are talking here about the computer vision, basically, where the computer has gone into a stage, or in addition to what a human eye can see and detect anomalies or find faults or detect errors and apply a fix over that, we are parallelly putting the machines to do this, right? So there human eye can get tired, there is a fatigue to it, but the machines don't have fatigue. So the first thing that you could see is the error that could be minimized when we put machines to do this job. And certain cases, hazardous area, human cannot go in, cannot use the naked eye to see certain things and take a corrective action on as it may warrant at that time. Again, the machines can do that part. So basically it's definitely going to help human in doing something which is more hazardous and more challenging, where the human could be used for something more on a strategic call,
Yeah.
to take something more meaningful and more of a creative thing that the mission at today's stage cannot do.
Yeah.
Right? So though there is a thinking capability, being autonomous, making its own decision, but there are certain things beyond that which definitely the humans can be used,
Yeah.
while not being engaged into this kind of a hazardous environment and things like that. So if you really look at, again, this calls for a lot of data, again, power requirements.
Yeah, yeah.
And the very useful area or very fitment that I would say that this could get in is the health and safety, the HSE part, basically. So all the safety requirement of industries, today most of the industries are adopting vision-based detection
Yeah.
of hazards, or there are cameras that are fitted on the earth moving equipment, even material managing equipment, basically like forklift or anything to move material from one place to another, or anything to move, anything to do excavation, basically. So these are all cameras that's been put across the equipment, something similar to your the cars, basically, the advanced cars which has 360 degrees. These are the cameras that's on this equipment as well, which kind of completely captures and also sees the in and around. The cameras are able to capture if there is any difference in terms of the standard patterns that it has already learned. People without the vest, people without the helmet, these are all very basic things that the systems, most of the systems are capable of doing. Additionally, there is a learning that the systems are capable of, and look at some particular pattern and identify those patterns and alert much ahead of certain incidents that could be predicted well ahead of time.
Yeah.
So to that level, it could contribute towards the health and safety of the workers, which again contributes towards a lot of loss of downtime. Right?
I mean to piggyback on that. So usually we tend to build systems based on performances, not generally on safety, because safety would be added later. We make it functional, performant, and then add safety to it. But as you said, like, we are now curating through AI itself safety systems and the governance behind it as businesses started to do it. How do you think businesses should handle this, the credibility, the authenticity of such decision making of AI systems by itself for safety based risk avoidances?
So when you look at making a machine completely autonomous to take its own decision and to take its own call, there are a lot of learning that has to go into the machine, and there are regulations, basically. So the regulations are anyone who wants to train a machine with millions and billions of data sets for it to understand and not to go wrong in any of those instances. Yes, you can make the system adaptable to that, and you can build such a robust system with stack of the solutioning that you could do on top of it, right, and make it work to that extent. But when it comes to the safety, you as human, you always have a kind of eye saying that not accepted that the machine would do this, right? So that barrier is now fading to some extent, because we could try it out in a particular area which is not going to be very hazardous, and after a number of hours of sweet experience, we can, and also certain things where it failed, the failure becomes the input for again the corrective actions.
Part of the learning cycle.
Typically the AI works on a failure model. So the moment it fails, it learns how to do it correctly. Right? So that adaptation has to be allowed. This is what I really see. If you take Waymo in San Francisco, you have this car completely autonomous moving around in all the places by Volkswagen. So it's a beautiful thing, and I would say it's more perfect than any human being can drive on those roads. The way it picks up the speed, the way it's cautious about stopping to the pavement, the way it is negotiating through the curves of the road. So these are all beautiful training that the system has had, and I'm very sure that's going to be more safer than any human. But again, there is a regulatory requirement, and as I said, there is definitely a adaptation to this that's happening,
Yeah.
with more stringent regulations to come, so that the machines can adapt to even that. And if those conditions are met, yes, we can definitely look at getting all this on board,
Yeah,
and still being safe. And humans could also make errors, right?
Yeah,
So
yeah, definitely.
so that's who is going to stay accountable. That
Yeah,
that
that's
becomes the
the
main
main bit.
main
Yeah.
element to it. So as long as there are framework, the legal
Policies.
or I would call it techno-legal kind
Yeah,
of
yeah.
system that's been established,
Informed,
where even the equipment which is autonomous itself to understand where it's what could be the legal implications towards certain things that it could do,
Okay.
right? So
Yeah.
that level of training models are being practiced
Yeah,
even
yeah.
now, and it's being experimented across
Yeah,
the
yeah.
world.
So I have two questions to ask immediately. So one would be, with your experiences in different engineering spaces and project spaces all around the world, especially in America, UAE, and here. Um, how do you see technologies that are built in a particular area for a specific purpose doing things wrong in different areas? How does that change? Because it's trained in one particular area, and then when applied on different areas, it behaves differently. How do you see that being handled effectively as we proceed?
I'm just thinking of some instances where it came into real application.
I'll probably give you an example where, say, Waymo. You give a very good example of it autonomously moving in the streets of US, stopping
same
where it
thing if
needs
it
to.
comes to India, may
Same
not
thing when it
operate.
comes to India,
May not operate.
may not operate.
Right.
But how do you think that adoption happens? They're just thinking out loud here because open discussion that we're having. So you think when a system like that comes in India, so say Waymo comes here, they want to start deploying a fleet of cars. What do they start to do? Like, I know initially they should start collecting data of Indian streets and
Obviously data becomes the first line.
Yeah.
And it's more of a connectivity that needs to be established. When I say
Infrastructure.
when I say connectivity, it's an obviously it all finally boils down to the data, because the more you connect with different disturbance elements or all that, it all generates data in some or the other form, which again has been layered into the next stage of collaborating these informations across different elements of the same AI model, which has been built in the particular car or that particular vehicle devices, whatever it could be, to adapt to that. So it's more of a training, more of a regulation compliance. Certain things, when I say training, that machine sitting in the other part of the world wouldn't have learned what it could not predict certain things.
I think edge cases would be
Edge case, obviously. So basically, you would not see that machine thinking of somebody who is going to just jump in, because there are the moment you see a payment, that's when the machine realizes, okay, there is a walkway, so I have to be careful. But here it doesn't really matter where there is a walkway.
You should be always alert.
You should be always aware. Machine is aware. The person who is walking is aware. So it's in a multi-directional or multi-dimensional
system that we, I think,
system that is
try
working
to
with,
adapt to, like the advent of traffic lights even. Because before that came in, anyone can do anything they want. Once they started establishing a system where red means stop, green means go, then as a people, as a community, we started understanding of what to do in a particular junction to regulate traffic.
Right. So it's more of an adaptation. Now, another thing is awareness. When you bring such certain systems into the new environment, the entire community has to be made aware. All the stakeholders have to be updated about what it is. You have to understand clearly what these stakeholders would have as an acceptance to it, right? If okay, you cannot be doing that level of a survey and things like that, but obviously a basic understanding of what a moving crowd here, a general public would adapt this, and what kind of a training or adaptation should be given to a general public, and say that, yeah, look, we are now going to introduce about 200 units of autonomous taxi in Chennai city or in Mumbai city, right? So there people are aware now,
Yeah.
right? So okay, there is a new mission that's going to come, we have to be careful, right? And we are ready to welcome this. So that kind of acceptance from the stakeholder and is necessary, and that calls for a stakeholder engagement. You have to engage with the stakeholder in some or the other form. I don't know how, but some or the other form, there should be an engagement model that you establish with the stakeholder, which is a common citizen of the of the city, and who knows, okay, I'm ready to welcome this. Why not? Let's see how this works, right? So there they have one step forward in terms of taking certain precaution at the initial stages, right? And you can deploy it in one particular area, test the soil in one particular geography within that city or whatever it is, and see how adaptation has been, and what kind of the learning that you do by bring it back to the lab and see, do your learning, and those iterative model to training with that iteration number of instances that you have to rework on it, is how you can bring certain things from a different environment into an environment which it has not seen before.
Yeah.
So to answer your question, anything that I could think of, example from my previous past experience, I don't remember anything where we had to adapt certain things from one region to other. But yeah, it's a good one. Not something that's occurring to me right away.
Yeah, because it's, I mean, not even different geological locations, different applications or different fields even would promote a change in terms of what the model is being trained on, or how it is being trained.
See, I can probably take an example of the enterprise asset management solution that we had been working with. So we had been working for maintenance repair overall, which is like aircraft maintenance and repair shops. So we build solutions for that, and that solution was initially on all the fixed wings for the aircraft maintenance. Like these are all typical aircrafts which are operated by the flight operators. So this system worked with different configurations of airlines, means aircraft manufacturers, be it Boeing, Airbus, or Embraer, or various. We wanted to try this on an helicopter, which is a rotor wheel.
Yeah.
So the entire configuration changed. There were at least about, we started mapping in to see how much of those parameters can be carried forward in the new development that we take it for. So we are looking at roughly about some 60-70% of matching that could go. And then we realized that it's not just that, it's more to do. But still, we went into a development phase. We developed the entire product, taking cut from there, and started fitting to all the helicopters as well, the same maintenance solution. So those are the shifts that you can always think. There is a way always, but the initial assessment and the way you lay out your business plan at the initial
stage. I think that's the stakeholder engagement, let it be internal or external.
True. Not just that, you also have to look at the investment opportunity there, what way you need to calculate your IRR, see what way it's going to really be a feasible solution that you get into certain movement from one catering to one particular sector to another one, or one domain to another one for that matter. So that does matter, but it is possible. But as I said, the initial stage where you really put your business plan really matters. The evaluations that you have to do at the initial stage, it does matter to bring in certain changes or adapt to a new environment, or switching to a new product line altogether.
Yeah. So diving deeper into an individual level, where say an engineer is like coding in his laptop, his or her laptop, and the code itself doesn't carry any liability because it's still in the laptop, it's in the dev state. But once it starts moving into like safety systems, energy systems, factories, suddenly you can see the failure being physical. How do businesses and people or engineers, with the advent of AI based coding coming in, how do like everyone manage this? Because I know like people can make mistakes and they can rectify it, but we have here something called vibe coding, AI based coding agents which code by themselves doing things what we tell them to do. But how do you see both of this synergize where mistakes is like a first point of view where it's like an iterative cycle?
So first thing I see on such cases, co-working is very important. Here we are working together with AI, we are working together with Robo, right? So at that point, necessary handholding at the initial stages are required to take it up to a stage where the learnings are perfect. But beyond that, as you say, if you really look at agentic or the AI writes its code and it's again put it to deployment by itself, and it has taken certain decisions to move forward and deploy it, certain actionable parameters going wrong. It's going wrong at that stage are to be already assessed in the risks.
Yeah.
So when you're putting this plan to go and deploy or to go and come up with a product or with a solution of that kind, when you're going to build over that, these are the risks that you assess at the initial stage, and have your mitigations plan accordingly, have your alternative plans of switching over. If anything goes wrong, you should be in a position to take control over the system immediately and put a stop to it, either remotely or whatever could be the environmental thing. You'll have to look at some kind of a hard stop that you should be able to put on such cases. And only when all these parameters that if it goes wrong, I'm in a position to get a control over it and could stop. So that's when certain things like that can be deployed. So it all comes at the initial stages where you really draft a plan for it and you bring it to an execution in terms of how you're going to operate this project, right? So when you start doing that, you already have the risks already identified. These are one of the risks that you're talking about.
Yeah.
So this risks does carry its mitigation plan, and also what if this risk turns into an issue, right? So those are already assessed, and what could be your action on certain events like that? How do you take control over it?
Yeah.
Right. So maybe you cannot wait for that instance
To happen.
for the thing to happen,
Yeah.
and then be lucky enough to be in a position to control that and put a stop to it. So that is just a chance. But when we are very sure that these are certain things that could happen, or we have a let's not say very sure, we have faintest idea that these are things that's probably going to happen with certain percentage to it, and the weightage that you put towards that, you definitely have to mark them as your risks and look at your plan to handle that.
Even on a individual level, as a engineer, you should be wary enough of that.
Individual level, engineer is a part of a program or a project. So it all comes into that system. So individual, if you are looking at an individual doing this as a startup initiative, yes, obviously it applies to him.
Yeah.
Because there is an ethical code line that you have to really follow and make sure that something that you create is not going to, damage others or, work on somebody else's property or create any kind of a consequential damages to somebody.
Yeah.
So that level of
I think it's even more critical now.
It's even more critical. Yeah. And you never know what kind of quick adaptations that system would take you to the next stage. So those are certain things that should be foresighted ahead of time, and have your risk plan properly drafted and reviewed on a periodic basis while you progress on certain projects like that.
Yeah. But it makes sense. It kind of ties in different questions that different areas that we spoke about. Meaning, if certain risk were to happen, one, even though we're not wary about such risks, we could collect data at that particular risk
Right.
events and then retrain as part of the cycle. One, to educate the individuals as part of the system, and the other to educate the agents as part of the system. Educate in the sense they execute certain functionalities better as they get trained on new kind of data in a newly deployed or newly tested environment. I think it makes sense.
Right. So those would be the lessons learned, which always gets incorporated, like how your AIs would also really work, right? So
Yeah.
it keeps working on the errors that it encountered, and those errors, how to bring that fix, eliminate those errors. So that's an adaptation that the systems could bring
Yeah.
when you venture into product building of that kind.
Yeah.
We
Scaling.
cannot stop, we have to keep building, right? So
Yeah.
so we have to look at various methods and methodologies that has to be followed to ensure that we still find the safe way of doing things.
Yeah.
Right? Obviously there are regulations which has the guidelines, allowances, stops, hard stops. So we'll have to really look at and build our product line with those boundaries, conditions, and ensure that we are still being in a position to move forward and start towards our development.
Yeah. Scaling it way up, removing all the buzzwords and everything, what does decarbonization mean? And how does it relate to the actual scaling of AI itself?
In simple term, I would say this is structured way of organizing your energy generation, industry, the way you handle your industry, the way you operate your agricultural and forestry area. So these all have changed over some time, and these have changed in a way that they found a way in their day-to-day operation to reduce the greenhouse gases emission, either to reduce or to remove it from the system. So this reducing or removing of the greenhouse gases, which is carbon dioxide, nitrous oxide, SOx, NOx, everything comes in there. So these removal or reduction of this gases in their activities, or in the way that the industry functions, or in the way that energy is generated, or in the way that chemical plant operates, or in the way that agriculture grows the plants with the carbon capture. So the way it could capture and remove it from the system is decarbonization. To make it very simple, you are removing carbon from the environment.
Yeah. Why should a normal person care about this?
Why should a normal person care about it? Because it, over a period, we all have seen that we are now looking at a deadline of about 2030, by which most of the countries have committed to be net zero. Right? This is required because of the climate changes.
Yeah.
The more we abate to this, the more we delay on this one and take it forward without caring about it, the next generation, or probably if we live long enough, we would face the problem of not living in a clean environment and facing all the weather bad conditions that we are facing, the heat and the respiratory problems. All this are the health conditions, contributions that it could make, right? So these are all adverse conditions that it could take us and the generations to come. So the entire world now is working towards, with their own commitments, what it has made to Paris Agreement, and that being a more of a governing and accepted level at which most of the countries are trying to follow this one.
Yeah, I think as a civilization, humans are generally constantly battling between exploration versus exploitation. We tend to exploit all the resources that we can, where we also try to explore into things that we will try to evolve ourselves into a newer system, a newer uh, newer strength as an entire humans. Concluding, with your experience, what is few things that you learned as a person, very at the stage that you are in, that you would tell young people in general?
I would tell that keep up, be responsible, no matter which country you are in, which country citizen you are in, be responsible in terms of what resources that you use from the what the earth has given, and otherwise we wouldn't have reached this stage, right? Basically, we all had been responsible at some or the other point,
Even on a
but that
micro
was not enough. This is what is the result of it. So that's one thing that I would definitely say, and rather than this getting mandated, a responsibility that grows within us would definitely make us a good citizen of any country. And in addition, in terms of the young generation who is now looking at following up their career and things like that, I would definitely say with the advancement in the technology, I would ask all the people to really upgrade their skills and stay up with it, because skills would die. So means I would not say it would die, it would fade off. There would be new thing that always comes, so you have to always keep upgrading. But what you possess already definitely becomes a foundation for the new learning. So that's basically what I would pass as a, my comment or my advice to the people.
Anyways, it was a very engaging conversation. I think many of people like us can really relate to the things that you were talking about, like on a very basic level, even. Thanks for keeping it at that level, and it's really engaged in terms of talking.
Likewise, I enjoyed
Thank you.
talking to you and sharing whatever I could.
Yeah.
It was wonderful talking to you.
Thanks.